We are the reporters, Bailon, Barela, George, Mamalimping, and Musa. So, activity 2, measuring mass. Objectives. Draw and label the parts of an analytical balance and indicate their functions. Define the different types of analytical balance and weighing techniques. Discuss the different weighing errors. Discussion. In most analyses, an analytical balance must be used to obtain highly accurate masses. It has a maximum capacity that ranges from 1 grams to several kilograms, and a precision at maximum capacity of at least 1 part in 105. Less accurate laboratory balances are also employed in the analytical laboratory for mass measurements where the demands for reliability are not critical. Procedures. Number 1, draw an analytical balance. Label its parts and indicate their functions. 2, types of analytical balance, describe each. 3, weighing techniques. Discuss the weighing techniques. 4, weighing errors. George.
Discussion pa lang dyan po sa nakabutang.
Nana. Sige,
Wala
ako na.
gyapon.
Ako na lang. So, in this part, we draw the analytical balance and name it, I label its part and indicate their function. So, makita man natin dari, karang i-drawing, karang may door handle siya, may balance pan, gear button, power button, level adjustment feet, display, level indicator, and shield draft. Kailangan siya shield draft para dili maano ang air god niya or something that can cause an error sa measurements. Tapos, ada yung mga explanation niya. Draft shields. It protects the sample from external environmental influences such as air draft. Thus, it helps to improve the general weighing performance. Display. It shows the information such as the result, error, functions in the progress, and information to function setting. Level adjustment feet. A device that adapts and ensures the proper leveling of the machines. Level indicator. It guides the user if the samples are balanced. Power button helps you in turning on or off the analytical balance. Air button. It resets the display weights on scale back to 0. Also, it is used to measure the multiple samples in the container. Balance pan, it supports the sample being weighed. Door handle, it acts the handle of the glass door. So, sa base explanation dere, madali naman maintindihan yung use niya, di ba? As a display, dito nakalagay yung kung ano ang measurement ng gi-measure natin. Tapos, ang door handle, paano i-open and close. Ang balance pans, it support daw sa object na dapat natin i-measure. Tapos, ang shield draft, as I said earlier, it protects from the air draft para dili mag-error ang measurement or can cause an effect. Types of analytical balance. Describe the following. Macro balance. Wait lang po. Makita ninyo, Nor?
Wala.
Hindi nag-appear.
Sa analytical balance pa rin.
Has started screen sharing lang akin.
How about the other classmates? What can you see sa screen?
2 types of analytical balance.
Analytical balance pa rin, ma'am.
Okay.
Ay,
Wait
kita ko
lang.
na akin.
Yung 2 types na po.
2 types na. Okay. Kasi
Ay na, okay na.
I can see 2 types of analytical balance also. Naghang lang guro sa ila.
So, padayon na ako. Two types of analytical balance describe the following. Macro balance, a type of analytical balance that is used to weigh smallest sample. It offers a capacity of up to 6 grams with readability up to 7 decimal places to the right of the decimal points. So, ang macro balance daw is na siya capacity to weigh 6 grams tapos hantod sa 7 decimal places to the right of the decimal points. So ang semi-microanalytical balance, a type of analytical balance that is used to weigh powders, drugs, and chemicals in smaller increments. It offers a capacity of readability of 0.01 milligram with up to 5 decimal places. So in every analytical balance, na sila different capacity to measure samples. Diba sa macrobalance na siya up to 7 decimal. Tapos sa semi-microanalytical balance is na siya up to 5 decimal places. Tapos microanalytical balance, a type of analytical balance that can weigh loads up to 200 grams to the nearest 0.1 milligram. It has the capability to measure the weights of minute and delicate objects. Single analytical balance, a type of analytical balance that is very sensitive balance used for weighing quantities less than 10 grams. This balance can accurately weigh quantities up to 0.1 milligram. So ang single analytical balance is yung analytical balance good yung may na siya shield kay sensitive man gid siya sa air draft that can cause error of measuring. Electronic analytical balance, a type of analytical balance that is accurate, which can give results up to 5 to 6 decimal places. So number 3 na ta. Weighing techniques. Discuss the following weighing techniques. Did you want makita, George?
Ba? Siya sa balance Japon.
Try mo daw si kanang ulit tanggalin mo
I-share?
yung share screen tapos ulit ko.
Sige. Para. Naya? Kere. Yan, or meron pa po? Yan, meron na po.
Yeah, we can see it.
Okay na, Sai.
Sige. Di pa rin makita, George?
Okay na sa akin side.
Sige.
Okay na.
Si George na mag-report dyan, di ba?
Opo.
Weighing techniques. So weighing by addition. This test is used an empty, dry, and clean weighing bottle for weighing the sodium chloride. It was initially weighed and recorded first before putting the sodium chloride added in the weighing cups. And lastly, weighing bottle and sodium chloride subtracted by the weight of the empty bottle to find the net weight of sodium chloride. So in this technique, um, in this weighing technique, they use the addition. So it used an empty, dry, and clean weighing bottle for weighing the sodium chloride. Then they it was initially recorded first kasi para malaman natin yung initial niya na weight bago siya ilagay sa sodium chloride na mayroong na added in weighting cups. Then lastly, yung weighing bottle and sodium chloride subtract sa weight ng empty bottle para mahanap yung net weight ng sodium chloride. Next. Sai?
Na next na po.
Wala gyapon sa ako, Sai.
Sige, wait lang. Nakita na, George?
Weighing by difference. The most accurate method to measure quantitatively the mass is weighing by difference. In this test, watch glass and reagents were used. First, we must record the initial weight of the closed container that contain reagents. Second, we must carefully add the 3 pellets of sodium hydroxide individually in the pre-weigh. Dried and clean watch glass, then weigh again its gross weight and solve for the weigh sample in the watch glass. Thirdly, reweigh the closed container containing the sodium hydroxide. And lastly, repeat the process but now use different reagents. Next. Sai?
Wait lang. Na next na siya. Hindi makita, no?
Sorry, ma'am. Problema lang sa connection, ma'am.
Ara.
Okay. It's inhibited.
Wala gyapon siya, Sai.
Ay, loading ang share screen mo. Okay, okay
Opo,
na.
ma'am.
Okay,
Okay
na.
na. Sige.
Hindi ako
sige.
choppy, guys.
Wala gyapon ako sa weighing by difference
Hindi
gyapon.
ako choppy.
Hindi.
Hindi man.
Okay. So, good morning, di. Sorry.
Ay, gani man
No,
dire.
tapos na ba? Sa weighing errors ako sige.
Hindi ako sa weighing error.
Yeah.
Tabangan pala kasi
Everything.
errors. Okay.
Tapos na?
Opo.
Saan na
Weighing
banda?
errors na. Weighing errors.
Okay. So, good morning, everyone. So, for the weighing errors, we have a test for effect of temperature and its weight, wherein it includes the use of a test tube to determine if different temperature can affect the weights of different samples. And for the inconvenience, use beaker to contain the test tube for stability in weighing, and then put the beaker on the top loading balance and press there for the balance to reverse at 0 for a precise and accurate result. And then weigh a clean, dry test tube and record its weight for the room temperature. So after recording, place the same tube inside the freezer for 1 minute and weigh again to see the result. Next. The next one na see? Loading pa.
Yes, loading pa. Ayan, nakita na?
Loading pa sa akin.
Sige.
Load. Okay na, okay na. Next is to place the same test tube on a Bunsen burner to increase its temperature for 2 minutes. after putting it on the freezer. And then immediately reweigh the tube and record its weight for comparison. Below are the result, which is we noticed that the temperature condition and the wait. See, wait lang, hindi pa ako tapos.
Sorry. Oh my God.
Okay. So we have noticed nawala imuhang ano. Kaloka to.
Hara. Sorry.
So we have noticed that the weight of the test tube has changed after putting it in a freezer and then putting it in a room temperature and putting it on the Bunsen burner, wherein the test tube that is cold weighed 14.02 grams, and while the room temperature test tube has a 13.99 grams weight. Yeah. Lastly, the weight of the hot test tube is 13.96 grams. So we noticed that there is a change on every temperature. And then discuss your observation and the procedure and the results of the experiment. So our answer is as we have observed during the experiment, the temperature can affect the weights of different samples. When a when a dry test tube was placed on a room temperature, the weight of the test tube is 13.99 grams. As we yeah. And then the test tube is placed inside a freezer for 1 minute, wherein the weight of the test tube increases due to the cold temperature that the freezer produces. While on the other hand, the same test tube is also put on the top of Bunsen burner to increase its temperature for 2 minutes. After this process, the weight of the test tube decreases due to hot temperature. So, di ba pwede pa balik dun? Ay, wag na lang pala. Ano yun siya? Cold is 30. Ay, pwede pa balik? Please.
Sige. Ayan, kita na.
Nag-loading ang share screen mo. See, wait lang.
Sige.
Sorry. Mas taas ba ang mas taas 'di ba ang temperature sa hot ay sa cold?
Oo.
Ay okay, nakita ko na, okay. So we notice here that the weight of the cold test tube is 14.0. Yun yung nilagay na natin siya sa freezer, which caused the test tube to parang like mas mataas yung weight niya, like mas mabigat compared to the hot, kasi syempre 'di ba pag magpainit tayo ng tas parang like mag-evaporate, mag-boil, so mag-change ang weight niya, and then okay. Gets nyo guys? Guys.
Oo.
Let's have the question
Ala, oy, kalok.
portion later. And then I will explain this further later also. Isahin ko na lang siya.
Okay. Okay, ma'am, thanks. Pa-next na si
Wait lang.
Okay na? Nawala ulit ang screen mo.
Sige, are.
Loading ulit. Wait.
Sure. Sige, sige.
Sobra si...
Hindi pa dyan?
Hindi pa. Guide question ka na. Wala pa tayo sa weighing errors pa lang tayo.
Oh my God. No.
Sobra.
Ara.
Loading, wait. Okay. B? Effect of more. Ay, joke. Sige, dyan ata. Yeah. Next is the effect of moisture gain or evaporation on its weight. And for this test, we use a watch glass containing NaOH pellets, ethanol, and sulfur. And then reweigh each sample using a top-loading balance. It is aimed to know if samples subjected to air have effect on the initial and latter weight, and record the final weight again. So so below are the result of the net weight of the samples. I mean the test tubes. I watched classes pala, sorry. So for the sample NaOH, for the net weight immediately after transfer, we have 0.70, and after some time, it increased to up to 0.93 grams, and the ethanol from 0.09, it increased up to it decreased pala, up to 0.03. Lastly, for the sulfur, it also decreased from 0.87 to 0.85. Next, see
Na next.
na. Wala pa sa akin.
Stop share ka na lang muna. Ara. Loading mo.
For the discussion of effect of moisture gain or evaporation, our answer is the observation and the procedure and the result of the experiment is that there is significant change of its weight in NaOH, where it gains weight from 0.70 grams to 0.93 grams. Yung sinabi ko kanina na nag-increase yung weight niya, yung net weight after some time. And in the ethanol, it lost weight after some time from 0.09 grams to 0.03 grams. And lastly, the sulfur also decreased after taking some time in the outside from 0.87 to 0.85 grams. It all because of the effect of the moisture gain or evaporation of three subjected to have an air effect. Yeah. I additional lang pala um when the water or sample evaporates, it loses molecules from its surface, which cause both its mass and volume to decrease proportionally molecule by molecule. Kaya nag-decrease yung net weight nung ethanol and nung sulfur kanina. And letter C, effect of electrostatically charged weighing materials. Number one, a clean, empty, and dry plastic weighing cup was weighed beforehand. And with the help of a wooden cloth, rub the cup using it for 1 minute. Then immediately weigh the weighing cup and record its weight. So this is the result of initial weight of weighing bottle 3.99094, and then weight of weighing bottle after rubbing with a wooden cloth, it decreased rather, and I up to 3.9087 grams. Panexi.
Tara, na
Na
next
next mo
na.
si?
Oo.
Wala pa. OMG, brown out.
Rana?
Hala, pag nawala ang net ko, brown out. Pa-next this. Okay na, wait lang. So our observation in effect of electrostatically charged weighing materials is the procedure and the results of the experiment. As we rub the cup in the wooden cloth, the electrical charge in the cup will transfer to the woolen pala, hindi woolen cloth caused by friction. That's why after we rub the cap, the woolen cloth from 3.9094, it decreases into 3.9087 because of the transfer of electric charges. That's why it caused the weighing cup to decrease caused by friction. And then next C.
Sige. Buoyancy error. A buoyancy error is the weighing error that develops when the object being weighed has a significantly different density than the standard weight. This error has its origin in the difference in buoyant force exerted by the medium or the air on the object and on the weight. Correction for buoyancy is accomplished with the equation. And wait lang yun. So the equation for the buoyancy error is W1 is equals to W2 plus W2. Wait lang. D air divided by the object minus D air divided by weight, where W is the corrected mass of the object. Wait lang yun. Where W2 is the mass of the standard weight. The object is the density of the object. The weight is the density of the weight. Wait lang gid now. D weights, the density of the weights, and D air is the density of the air displaced by them. D air has a value of 0.0012 grams per cubic centimeter. Wait lang, galoding pa. Wait lang gid. So answer the problem. A bottle weighs 7.6500 grams empty and 9.700 grams after introduction of an organic liquid with a density of 0.92 grams per cubic centimeter. The balance was equipped with stainless steel weights. D is equals to 8.0 grams per cubic centimeter. Correct the mass of the sample for the effects of buoyancy. Show your solution. Wait lang. So, ang given is bottle weight is equals to 7.6500 grams and 9.9700 grams. The air is 0.0012 grams per cubic centimeter. The object is 0.92 grams per cubic centimeter. The weight is equals to 8.0 grams per cubic centimeter. So, ang solution na to is to get the standard weight, we must subtract the 9 point. Ay, nagaloading pa sa inyo, Dera. Tara na. To get the standard weight, we must subtract the 9.9700 grams minus 7.6500 grams to get the 2.3200 grams. So, i-ano na lang natin sila. So 2.2300 grams plus 2.200 grams. I-add na sila tapos 0.0012 grams per cubic centimeter divided by 0.92 grams per cubic centimeter minus 0.0012 grams per cubic centimeter divided by 8.0 grams per cubic centimeter to get the corrected mass. So W1 is equals to 2.3226787 grams or 2.3227 grams. Guide questions. So guide questions. Give a generalization of the effects of temperature on the weights of materials. Answer. Temperature has effects on the weights of the materials. If the object is in the room temperature, the weight of the object still remains. When the object placed in the heat It will lose some of its water due to the evaporation. And lastly, when we place the object inside a colder environment, it will gain some weight due to the water that has been solidified due to its freezing points or coldness. So guide question number 2. George, makita ni mo ka, no?
Ako na?
Oo.
Okay. Give a generalization of the effect of moisture gain or evaporation on the weight of materials. When heat is produced, moisture and evaporation are also present. These activities are responsible on the weight reaction of the samples. This made the materials vary on its weight, for some of the chemicals increase and decrease their weight due to the pressure caused by heat. Next. Kasi nasa number 3, Sai.
Give a generalization the effects of weighing electronically charged materials on its weight. Answer: when the weighing cup is rubbed with a woolen cloth, friction is present. This activity is responsible on the weight reaction of the sample. Due to the effect of friction, the weight of the sample decreases. So in guide question number 4, discuss the precaution in using analytical balance. Answer. Our answer is, in using analytical balance, first we must set the analytical balance into certified standard weights. Then we must ensure that when we put analytical balance, we must put it to the place that is vibration free because it can cause an error. Also ensure the area has a perfect temperature because the temperature can affect the measurement of the analytical balance. Lastly, we must handle it with care and use it correctly. So our conclusion is, this experiment enables us to familiarize and know the function of each part of the analytical balance. We also describe the different types of analytical balance, weighing techniques, and weighing errors, and know how to solve for buoyancy errors. And when we use the analytical balances, we must ensure that the place is at room temperature and far from disturbances that might cause an error during measurement. That's all. Thank you. Thank you.
You have questions, class, that you want to ask the reporters? Wala? Sige, can you unshare your screen, Sai? Okay. Sige. Uh-huh. Okay. So I'll be discussing it thoroughly, the results of the activity number 2. So activity number 2 is entitled Measuring Mass. Your subject class is Analytical Chemistry. So this is concerned with analysis, testings, and when you want to test something, the most important thing is accuracy. Therefore, it is very important for us to know how to properly handle the equipment na ginagamit natin sa pag-measure. So, the first one is measuring mass. Okay? So, na-discuss nila. Yeah, it's okay. It's okay. Yung problema sa internet connection, it's inevitable, so we cannot do something about it. Okay lang kahit nagputol-putol. Okay, let's discuss the parts and function of analytical balance. So itong picture na nasa screen, this is an example of an electronic analytical balance. I hope that is clear. This is an electronic analytical balance. So sa laboratory class, marami tayong balances. Klase-klase, may top load na balance, yung nilalagay mo lang on top yung object na wini-weigh mo, and then meron tayong mga common balances lang, no, pero they are less accurate. So pag sinabing analytical chemistry, since we are very concerned with accuracy, the only balance that we can use is the analytical balance. So, sa laboratory sa ating school, marami tayong balances but we also have analytical balance dito. So, pwede nato to siya gamito. Now, these are the parts of the analytical balance. You have there the weighing chamber. Ganito talaga ang itsura ng analytical balance class. It is enclosed. Meron siyang chamber. So, that is just to eliminate any influence by the air. Kasi analytical balance is very sensitive that even airflow can cause variations and error in your measurement. Okay? And then, this one is the level indicator. This one, itong bilog na ito. Depende kasi siya sa balance. But makikita nyo sa any balance, yung bilog na yan. Wait lang, i-draw ko na lang siya. Okay. Sa mga balances natin, may makita talaga kayong bilog, and then inside, meron pa siyang another ring. So, ang purpose nito is to actually install the balance level. Yeah. And then, before natin gamitin yung ating electronic analytical balance, we have to make sure na nasa gitna itong ring. Nasa center talaga siya. Kapag hindi yan naka-center yung ring na yan, it will indicate na hindi balanced yung iyong analytical balance. So, hindi siya magbibigay sa iyo ng correct measurement. Okay? So, this is the balance main body, and then you have there the display where you can see the measurement. So it depends sa analytical balance na available. There are analytical balance that can give you mga 6 decimal places. So that's how accurate it is. And then, ito 4 decimal places lang yung display niya. And then, we have the level screw. This is, ito sa ilalim. Ayan, level screw yan siya. This is being adjusted when we want to calibrate our balance. So, for example, nakita nyo, itong level indicator na ito, hindi naka-center ang ring. So, para mag-center siya ulit and pwede nang gamitin ng ating balance, we can adjust the level screw. So, para pantay-pantay na lahat ng paa ng ating balance, ayan, nakalibrate siya tarong. Level screw ang ginagamit natin to adjust. Okay? Next, as you can see, we have doors here, we have door here, and then on the other side also, and on top. Okay? Tatlo talaga yung door ng ating analytical balance class. We can open it if we want to place our sample inside when we want to weigh something. But make sure na before reading the result, we have to close everything. Because again, just as what I said a while ago, there is influence of air sa measurement. Okay? And then we have the pan where we place our sample. Diyan, yan yung mag-support ng sample or yung object natin na i-weigh. And then we have anti-draft ring. This is the pan in the center, and then the one outside is the anti-draft ring. So this will reduce the influence on measurements from the air drafts. Okay, so whatever is the air flow or air na trap inside the anti-draft ring will reduce its influence para hindi maging mali yung ating result. And the key panel where you can see the switch and other na mga buttons na ay buttons din ha for on and off. And then we also have settings na button if we want to calibrate or if we want to change the unit. Kasi sa analytical balance class, pag electronic siya, you can choose whether you want to um, use the unit kilograms, pwede ding grams, pwede ding milligrams. So sa settings mo na siya na button, i-set. And then we also have buttons for tarring. So when you say tarring, pinupush natin yung button na ito if we want to kana mag-zero ang ato ang display. Okay? Nahimo ni siyang zero kayo. Usahay man good, kana ganing na ay mga particles inside o kaya na ay effect ang airflow. Usahay man good mag 0.0001, 0.002. So to ibalik natin sa zero ang ating display and mag-start talaga siya sa zero when you want to weigh something, then you just push the tarring na na button. So sa high dili na siya tarring ang nakabutang or tear or zero ang nakalagay sa button. So these are the parts of our electronic analytical balance. Questions, class? Wala? Have you used an analytical balance dati?
Yes, ma'am.
Okay, very good. So you have used this kind of balance. I hope when you used it, you checked first the level indicator if it's really in the center para balance lahat ng paa. Kasi pag hindi yan siya balance, there will be error in your. It will still give you a measurement, but you cannot fully trust the result kasi pwede siya mag-error if hindi yan siya naka-level. Okay? So pag sinabing analytical balance class, weighing instrument ito. Depende sa available na analytical balance. Merong analytical balance na can measure up to 1 gram only, but there are also available na hanggang ilang kilograms. So depende na yun siya sa available na analytical balance. And the precision ng kanyang binibigay na na result will be at least 1 part in 10 to the power of 5 at maximum capacity. Okay? So, ang precision and accuracy of our modern na analytical balance actually exceed 1 part in 10 to the power of 6 at full capacity. I'll be giving you a copy of this slide later for your reference. So, next week na tayo mag-quiz. Now, we have types of analytical balance. We have macro balance. From the name itself, macro. So, meron siyang maximum capacity, malaki. Maximum capacity between 160 and 200 grams. And yung measurement na makuha mo can have a standard deviation of plus and minus 0.01 milligrams. So that's how precise it is. Meron lang siyang mga variation sa result, mga at least 0.01 milligrams plus or minus. And then, semi-micro analytical balance. So medyo, mas maliit yung kanyang pwedeng ma-measure. It can be 10 to 30 grams, but the same precision capacity. And then, ang pinakamaliit, we have the microanalytical balance na ang capacity lang is 1 to 3 grams. So, maliit lang ito siya na ang balance. Okay. So, sa school, we have a macroanalytical balance class. It can measure even more than 200 grams actually. Yan. Sige. So actually, ang traditional natin na analytical balance, may dalawang pans like this one. So, gagamit, ito yung gagamit tayo ng weights, ilalagay natin yung object natin dito sa opposite pan, and then on the other side, we will be placing weights. So hahanapin natin ngayon kung ano yung anong weight ang magiging level sila. So dapat balance silang dalawa. And kung ano yung weights na gagamitin, yun na din yung magiging measurement ng inyong object. So yung mga weights na yon may mga certain na sila na known mass. Okay? But ang ginawa nila after the double pan, we have the single pan analytical balance, which is more convenient na gamiton kaysa sa traditional na analytical balance. So this is how a single analytical balance looks like. Yung pinakaunang single pan analytical balance was made by Ortling sa London, England, no? So, pwede siya maka-measure 100 of a gram using a substitute of weights. Just like the double pan, gumagamit pa rin siya ng weights like this one. Mga built-in weights niya. And papalitan yan siya depende sa i-weigh mo dito na object. So, kung ano yung magkapareha na weight, yun na din yung magiging weight ng object mo. So, move lang itong mga levers dito and mga rods and mga knobs until class na magla-light yan siya dito. Pag nag-light na ito dito, class, it means tama na yung weight ng iyong sample. So, kung anumang weight ang nakalagay dito, yung mga known na weights, and then nag-light na itong optical system light or optical system lamp dito, it means meron ka ng reading sa measurement ng iyong sample. So, that's single analytical balance. Kaya lang mahirap kasi magpapalit-palit ka ng weights hanggang makuha mo yung tamang weight na magkakaroon na ng lighting of the lamp. So, kaya it's better to actually use the analytical balance. The electronic, let's make our lives easier. We don't have single pan analytical balance and double pan analytical balance in the school. We only have electronic analytical balance. Kasi pag electronic analytical balance, lagay mo na diretso yung inyong sample sa pan, and then it will just give you, sa kanyang display, it will give you the reading or the measurement of your sample. So, meron tayong dalawang techniques sa pag-weigh. So, again, techniques ito in weighing. Meron tayong weighing by addition. So, actually, mahirap siyang intindihin kung words lang yung babasahin natin. So, let's watch a video on how to do. Again, the second technique is weighing by difference. So this involves repetitive weighings of a weighing bottle containing a quantity of solid reagent. And please take note, class, that weighing by difference is actually the most accurate method. Mas accurate ito kaysa sa dun sa weighing by addition. Now, this is how you're going to do weighing by difference.
Ma'am,
Yes?
dili pa mas accurate ang by addition ma'am kay murag wala ba siya residue na maano?
Wala siya?
Wala yung mga residue mabilin ma'am.
Wala. Actually, may residue siya na mabilin dito kasi ang beaker na imong gigamit is not really the exact na apparatus na imong gamiton when you will prepare your solution after. So ibalhin man gihapon nimo to. And at the same time, mas accurate jud ang weighing by difference kasi wala man gud nimo gikuha-kuha ang imuhang bottle. Igura nimo gi-weigh dayon tapos gibalhin ang unod unya gibalik nimo og weigh. Whereas kung nag-weigh kadaan og beaker tapos pagkahuman gidala na nimo siya asa-asa kay magdagdag na pud ka. So ano siya? mas dako ang iyahang difference when it comes to the result kapag ka ing ato addition ang imuhang himuon. Kaya di ba sa addition, i-weigh nimo una ang beaker, butangan nimo siya sa imuhang sample, tapos i-weigh nimo siya ulit. Niya i-minus na lang nimo. Sa weighing by difference, ang imuhang bottle, sudlan nimo daan og imuhang sample. Take note na ni gamit sila top load balance ha katong gibutangan nila gitungtungan nila. That is actually to kanang i-approximate kay example require ka na mag-weigh ka og 1 gram. So para na approximation na 1 gram na tong imong sample sa sulod mo gamit sa kag top load balance, and then ibalhin mo siya sa analytical balance. So you will get there, una nimo makuha ang weight ni container plus the sample. Tapos i-transfer nimo ang imuhang sample dito sa imuhang flask or any apparatus nga mao jud imuhang gamiton during the experiment or during the preparation of the solution. And then ibalik nimo og butang ang bottle dito sa sa analytical balance, and then makuha nimo ang iyahang result, and then it's the same thing, i-minus gihapon nato. Weight of the container plus sample minus weight of the container, you will get the weight of the sample. So accurate gihapon ang bisan pag naay nabilin dito sa bottle, it doesn't matter kay wala na siya na-appeal sa counting. Bale dito lang siya na-appeal sa weight sa bottle pero na minus man to nimo. So dili siya ma-appeal dito sa weight of the sample. Minus nimo siya kay di ba weight of the bottle unya na ay mga residues gamay na bilin dito, na include man to siya sa weight sa bottle. So ma-minus gihapon nimo. Wala siya nasali sa imuhang final weight of your sample. So this one is the most accurate method when it comes to the measurement of solid sample. So baliktad silang duha ha. Questions pa? Wala? So, sa laboratory actually, ang mga estudyante may problem with the weighing, no? Kaya as I have observed them, looking at them, ginabutang nila ang beaker sa pan, tapos ginadugangan nila og sample. Wait lang. Ano nila ang ginahimo dito sa mga estudyante kay ginabutang nila ang beaker sa pan, i-tear nila ang analytical balance para mahimo siyang zero. Tapos ginabutang nila ang sample. And then diretso na ang ilahang reading. So actually sa analytical chemistry, that is not proper nga i-tear nimo para mag-zero tapos madiretso na nimo kuha ang weight sa imuhang sample. Kaya na zero naman siya bisan pag naay nagtungtong na beaker. So that is not accurate and that is not accepted sa analytical chemistry. So either you use the weighing by addition or weighing by difference. Yeah, magka-error na siya kay naamay nagtungtong na beaker dito sa imuhang pan. Imuha raman siya, igo ra nimo siya gi-tear. So ang beaker dito nga nagtungtong sa pan bisag nag-zero siya, it can be a source of variation, mahimo siyang interference kay naa siya influence dito sa mga weights sa ilalom and sa reading. So dili dapat atuon, either you use again the weighing by addition or weighing by difference. So nakita na ninyo ang steps to be followed in weighing by difference. Questions, class? Wala? So naatay mga weighing errors. So na-mention ni nila sa report nila kagaina: temperature, moisture gain and evaporation, electrostatic charge, and buoyancy error. Kung tanawon ninyo itong results sa experiment dito, class, ang effect jud sa temperature is kapag kabugnaw ang imuhang substance, mas dako na ang iyahang weight compared kung i-weigh nimo siya at room temperature. And kung hot pud ang imuhang sample or warm, lighter pud na siya. Okay? kay naay effect ang moisture din ha, or we call it dynamic buoyancy. So, unsa ang mga sources of error sa difference in temperature? Una, kanang convection currents within the balance case exert a buoyant effect on the pan and the object. When you say convection current class, ano ni siya? Transfer of energy. So, habang nag-transfer ang energy kay naa may difference sa ilahang temperature, magkaroon siya og influence dito sa pan. So, magkaroon og um, variation dito sa imuhang reading. And then, kapag ka-warm po ng imuhang substance, so warm air trapped in a closed container weighs less than the same volume at a lower temperature. So pag init ang imuhang sample, there will be air, warm air na matrap, and that will cause na mag-lower ang iyahang temperature. Okay? And take note class na before weighing, kailangan i-cool down sa nato para makuha jud nato ang atoang desired and exact temperature. And kung gikan pud siya sa freezer or sa ref, because there will be times na atong i-weigh na material gikan sa ref, atuwa sa siyang cool, pa-room temperature sa pud nato siya. Okay, para exact pod ato ang measurement. Okay? Ang inyong tandaan, pag cold, mas bugat. Pag warm, mas gaan siya because of the warm air. Mas ano siya class, mas gaan siya basta na ay mga warm air na matrap. Mugaan kay dili kay siya ma-detect sa imuhang pan. So mas gaan imuhang makuha na measurement. So kana lang. So pointers, again, acclimatize samples before weighing. Do not weigh your samples directly either from the ref or the oven. Okay? And then use tweezers because putting your hand into the weighing chamber will cause it to warm up and it will cause variation sa results. Okay? Another thing, we will be using sample vessels na may small surface area kay mas dali siya mag-acclimatize or mas dali siya ang iyahang temperature kay mas dali ma-achieve na maparehas siya sa room temperature. And please take note that never place your balance dito sa mga naay kanaganing like duol siya sa window kay syempre ang heat pwedeng diretso like sunlight and kanang may mga radiators because it will affect the measurement. So that's for the temperature. Questions, class? Sa temperature?
Ma'am, pag ibutang gud sa desiccator ang sample, di siya kaunsa na like in temperature.
Dili siya maunsa kung ibutang siya sa desiccator kay ang desiccator class diri na siya mag-fall sa moisture gain and evaporation. Pag ibutang nimo imuhang sample sa desiccator, it means you are drying your sample. It means you are getting rid of the moisture kasi ang uban nato nga powder class naa sila'y kanang water na molecule sa ilahang structure and then it can add to their weight. So before weighing, pwede na to i-dry ang ato ang sample using a desiccator. Sulod na to siya sa desiccator and then the silica gel beads will just absorb the moisture. Yes, pagbasa ang sample tas ibutang siya inside the desiccator, mag-decrease ang iyahang weight because the water in your sample will be absorbed by the silica gel beads inside the desiccator. Okay? So, namang good ta class, sa hygroscopic na substance. Kaning hygroscopic na substance, mo ni siya atong mga chemicals na naa sila'y ability to absorb moisture sa air. So, class atong air na ay moisture, especially diri sa Philippines. Ang Philippines, we belong to zone 4. Ang ato ang climate diri kay hot and humid. So, init, pero ang ato when you say humidity, diba, it's the amount of moisture sa air. Naay water vapor ato ang air daghan. So hot and humid ta. Now, pag ang atong substance kay ang tawag sa iya kay hygroscopic, i-absorb na niya ang moisture from the air and then it will add up to its weight. So example ana dito sa sa activity kung basahon ninyo, it's the sodium hydroxide. So natay sodium hydroxide pellets, solid na siya. Pero pag pasagdan lang nato atong sodium hydroxide pellet, dili nato siya takluban, dili nato siya i-store in a closed container, i-absorb na niya ang moisture sa air, and then once you weigh it, it will become mahimo siya mas bugat compared to its original weight. Mao na siya ang example sa hygroscopic na substance. Yes, mag-increase ang iyahang weight. Actually, ang sodium hydroxide, kung daghan na kaayo nga moisture iyahang na-absorb sa air, mahimo na siyang liquid. Kadugayan, matunaw na ang iyahang solid na part because of the moisture nga gi-absorb niya sa air. Pero dito sa experiment, since dali lang man iyahang exposure to air, then ang makita lang nato is the increase in the weight. Ang atong problema pod kung volatile atong substance like the ethyl alcohol. So si ethyl alcohol pag ibutang pod nimo siya sa container na open, mag-volatilize po na siya. So what happened to the weight? Syempre magbaba kay nag-evaporate na imuhang substance. Okay? So mao pod na ang mag-cause og weighing errors, ang moisture gain because of hygroscopicity and loss due to evaporation. So what are you going to do if your substance is hygroscopic or volatile? You have to use a weighing vessel with narrow necks, kanang like sa volumetric flask, taas iyahang neck and then gamay para lesser pud ang mag-evaporate or lesser ang air nga makasulod. So para sa mga hygroscopic na material. And then we have to really use closed container. Dapat na i-cover or na ay stopper. And i-clean na to itong weighing pans sa any dirt or water drops kay ma-absorb yun na sa atuang sample, especially if it's hygroscopic. And then, another cause of variation is the electrostatic charge. So pag ang electrostatic charge man gud na mag-cause man gud ni siya unstable na weighing values because of drift and poor reproducibility. So ang ginaapektuhan jud ani niya kanang mga low ang conductivity ng mga materials or substances such as plastic, glass, and powder because of friction. Kasi ang electrostatic force either mag-attract siya or mag-repel sa imuhang container, so it can cause variation sa imuhang result. So mag-unstable pud ang imuhang weighing. Therefore, to get rid of the electrostatic charge kanang sa friction bitaw, di ba mo to sa activity no kay ang imuhang container imuha siya siyang i-rub. I mean, i-weigh nimo siya una tapos i-rub nimo siya and then i-weigh nimo siya ulit. So unsa inyuhang na-observe din ha, di ba ni gamay ang iyahang weighing because of the effect of friction in the charge. So naaman na siya charge involved, electrostatic charge. Okay? So habang nagawala ang iyahang charge, nagaano pod, nagabalhin ba, nagalahi-lahi sad ang weight sa imuhang substance. So after rubbing kay mag-dissipate naman na magbaba na ang electrostatic charge, mawala na siya. So pagbutang nimo sa imong weighing pan, lahi na iyahang result. So, para ma-avoid nato ang electrostatic charge, we may use anti-static instrument na pwede mag-neutralize ani na mga charge. So, example ana, mga gloves, weigh boats, and kung magamit tag vessels, kanang mga anti-static vessels like glass or metal weighing vessels. And then we have to maintain our air humidity. Again, humidity refers to the amount of substance, amount of moisture in your air. So above 60 degrees Celsius, 60% para lesser pud ang charge sa atong substances. Okay? And then buoyancy error kani ang maapektuhan ani kapag ka ang weights dili pareho. Sa electronic ka balance, I think that's okay, but kung single pan balance nga, you will be using weights na kanang mga weights na known na daan ang ilahang weight or ang ilahang mass. Dira ta magka problema sa buoyancy error kasi nai-effect ang different densities sa weight og sa object because of the air or other na mga na mga reasons aside from the air hub or medium, na-effect ang buoyancy or buoyant force din ha. So kailangan nato siya i-correct. So naatay formula na ginagamit for buoyancy error. This one, W1 equals W2 plus W2 times the density of the air divided by density of the object minus density of the air over density of the weights. Again, ginagamit lang nato ni if there is difference between the density of the object na wini-weigh natin and the density of the weights na ginagamit. Okay? Labi na sa double pan class, di ba sa double pan kay kailangan pantay na silang duha, balance jud sila, equilibrium. Tapos kung lahi ang density sa atong weights, dili siya magpantay dito sa atong object, kailangan nato i-correct. So W1 is the corrected mass, ang W2 mao ni atong na-measure na mass sa ato ang object. And then density of air class is constant, that's 0.0012 grams per cubic centimeter. Ang density sa object ug sa weights, ihatag na siya sa problem. So just like this one, so a bottle weighed 12 na no, sorry, I'll just extend a little lang. Just like the problem, example problem, a bottle weighed 7.65 grams pag empty. Tapos pagdugang nimo sa object, nahimo na siya 9.97. So this is weighing by addition. I-minus lang na nimo ang 9.97 minus 7.65 para makuha nimo ang weight sa imuhang object or sa imuhang sample. Now, ang density daw sa atuang liquid is 0.92 grams per cubic centimeter. Kanya ang balance nagigamit is nagagamit pud siya og stainless na steel na weight, and then take note of the density. It's 8.0 grams per cubic centimeter. Therefore, you can see the difference. Layo ra ang density ni weights sa density sa atong liquid. So, mostly ginahimo nato ni siya class ang correction of the mass because of buoyancy error kapag ka liquid mostly atong ginaway. Kana, i-correct nato. So, ang gina-require diri sa problem is to correct the mass of the sample for the effects of buoyancy. So, show your solution. Kani wala lang nako ni gi-round off. So, 2.32. Now, asa gikan si 2.32? This is from kani 9.97 minus 7.65. Weighing by addition man ni na kay weight sa imong bottle na 7.65, tapos pagbutang nimo sa imong sample nahimo na siya 9.97. So weight of the bottle plus the sample minus weight of the bottle, that's 2.32. Let me correct it later. This is 2.32. Now the density of air is given 0.0012, as well as the density of the objects and the weight. So i-substitute lang nato dire, 2.32 plus 2.32 times density of air 0.0012 divided by density of object 0. Let me correct this. This is, wait lang ha, ano nadugangan man siya 0 dira. Okay. Ayan. So 0.92 and then 8.0 grams ang sa weight. I-divide sa nato ni una klase. You divide this part, 0.0012 divided by 0.92 minus ang answer aning 0.0012 divided by 8. So pag nakuha na nato ang ilahang difference, then we multiply it with the 2.32. Okay? And then ang product, i-add dito sa 2.32, you will get the corrected weights. Again, ginahimo lang nato ning correction of the weight due to buoyancy error kapag layo lang ang difference sa density sa sample o density sa weights na ginagamit. Mostly, mahitabo ni siya kapag liquid ato ang ginaway. Okay? So, precautionary measures in using the analytical balance, syempre, you have to make sure that ma-center ang load on the pan, and then i-protect nato ang balance from corrosion. So, dili pwede nga idiretso nimo sa pan ang object na imuhang i-weigh. So, dapat dili siya non-reactive siya na mga metal, plastics, or other inert materials. Ang sudlanan, dili siya mo react with the pan. And then, especially if liquid atong i-weigh, no, we have to make sure na walay spillage na mahitabo. And if kailangan og adjustment ang pan, you can consult your instructor if dili pa mo kabalo mag-adjust. But dito na to siya i-adjust sa tail niya na part. Okay? You have to clean the pan. You can use the hairbrush para mawala tong mga spillage, especially mga powder. And before before weighing a substance, we have to make sure na dili siya init, dili pud siya bugnaw. Okay? And use tongs or finger pans to prevent the uptake of moisture by dried objects. Katong kagaina sa video, nagagamit siya finger na tawag ato. But we don't have that sa school man good. Okay na kasi ang gloves. Ang purpose lang ato para dili maka-add sa measurement sa mass ang oil sa imuhang kamot. Okay? So that's it for activity number 2. Before tayo mag-quiz next meeting, class, I'll entertain questions about this kay medyo kulang na ako ang time. So duha tong quiz next meeting, Monday, we will have our quiz sa mole and sa laboratory, the activity number 2.